Chapter 5, Section 4, Question 1. We're going to factor out a GCF, which is the greatest common factor. But before we can do that, we need to write the terms in descending order, then factor. So if we look here, from back in Chapter 5, Section 1, we have the invisible 1 and a 4. So this has a degree of 5. 3 and 3, this has a degree of 6. 2 and 2, this has a degree of 4. That way we know first term, second term, third term. Descending means it's coming down. Ascending would mean it's going up. So, step 1. I would give you half credit for writing it in descending order by degree. Then you have to factor it. When you're factoring out the greatest common factor, if this polynomial starts with a negative, in our textbook you have to factor it out. So that's only when it says factor. If we're multiplying it together and you end up with a negative in the front, you don't factor it out again. So this one, because it says factor and we have a negative there, we're going to take that out. We're then going to look at the numbers. All of these are divisible by 3. Then we're going to look at the x's. When we're looking at the x's, we want the smallest degree, so 3, 1, or 2. 1 is the smallest. Then we're going to look at the y's. y3, y to the 4th, and y squared. Y squared is the smallest. This is what we're going to take out of every single term. Some students will actually write a division, but if you're actually dividing it, it goes away entirely. We're not making it go away entirely. It goes in the front here. So I'm going to need you to do this kind of in your head. The negative goes here, so this will be a positive. 30 divided by 3 will give me 10. I had 3 x's. 1 went out here. The other 2 are inside. 3 y's. 2 went outside. 1 stays on the inside. The negative went out here. 15 divided by 3 gives me a positive 5. The x came out. 2 of the y's came out. So 2 of the y's stayed in. A negative came out. So if you think about it, a positive is kind of made up of 2 negatives, so when you divide it out, this is going to be a negative because the distributive property would then say a negative times a negative is a positive. 24 divided by 3 is 8. We took out one x. The other x is still here. We took out both y's, so there are no y's left there. That is the answer. Half credit, full credit. Make sure that you write the answer. Make sure that you keep that greatest common factor in the front. And if you ever want to check it, box this answer, of course, but distribute this, and you should get this back again. Chapter 5, Section 4, Question 2, Type 1 of 2. That means that on your test or something, we could have either of those questions. We need to factor this. In the last problem, we learned about factoring out the GCF. This one also has a GCF, but I'm going to show you one extra step that will help it make a lot more sense. We've learned about exponents. So 2x minus 1 squared is 2x minus 1 times 2x minus 1. We did that earlier when we were multiplying, and it's very useful here as well. When we're looking for our GCF, greatest common factor, we want to know what is in the first part before the plus or minus, and also in the second part. They both have a 2x minus 1. So I'm going to take the 2x minus 1 out in the front. Notice it still has parentheses, and then bracket. I still have a 3x. There were 2x minus 1s. I took one of them out, so the other one, doesn't matter which one, stays here. I took the 2x minus 1 out, and so this plus 5 stays here. Now, I see a wonderful Chapter 1 distributive problem here. Make sure that this is not the amazing disappearing, reappearing binomial. It has to be on all these lines. And if I were to distribute, I would get 6x squared minus 3x plus 5. Be careful. I've had some students who have gotten the 15x here because They didn't stop when the parentheses told them to stop. We have a binomial in front of a trinomial. If we had a monomial, it would go in the very front. I need to see this for half credit and this for full credit. This just makes it make a lot more sense. Chapter 5, Section 4, Question 2, Type 2 of 2, yay! All right, last time I had you write them all out, and this time you don't have to. Does that make it easier? Maybe, maybe not. So what do both of these have? This has a 3x plus 5, this doesn't. This has a 2x minus 1, and this has a 2x minus 1. The GCF is 2x minus 1. I'm going to use a bracket because I like using a mixture of brackets and parentheses. So since I know that this will have parentheses, I kind of go back and forth. So we have a 3x plus 5 in the first spot, minus. This was taken out, this was taken out, so 5x minus 7. And notice that I left them in parentheses. Back in chapter 1, we learned with parentheses, without parentheses, and then you can add and subtract. Same thing's going to happen here. So this one has the parentheses. Because there's nothing to distribute in the front, we can just bring that down without the parentheses. Here we're going to have to distribute the negative. That has caused us problems since chapter 1, chapter 2. It's going to cause us problems here. It's going to cause us problems in chapter 6. Make sure you can distribute a negative. Negative times 5x and negative times minus 7, so that makes it a positive 7. Then we can combine like terms. X's go with X's. Plain numbers go with plain numbers. And you'd think you were done. But my students have called this an evil math teacher problem because you think you're done, but you're not. If you look here, first of all, it's starting off with a negative. Second of all, these are both divisible by 2. So you're going to take out the minus 2, but you're not going to write them in the middle because that would suddenly become a subtraction problem. That is going to be a monomial, so it's going to go in the front. Nothing happens to this. And when we take out a negative 2, we're left with x. When we take out a negative 2, we're left with minus 6. That is your answer, and we do want it in order of monomials come before binomials. Now, if it makes you happier to switch the order on these two so that these could be next to each other and it maybe makes a little more sense, that's fine. By what property from chapter 1? That would be the commutative property. Gosh, we keep going over these properties. Maybe it's going to be on your midterm and or final. Chapter 5, Section 4, Question 3. We're going to factor by grouping. This is the first time we're factoring by grouping, and it's an important concept. And we're going to be using it in Chapter 6 again. GCF first. We just learned how to do GCFs, so that's wonderful. These are not written in descending order by degree, and I'm not going to ask you to rearrange them. We're going to do the GCF first. I can divide by 3 and 2. I can only divide it by 3. I can only divide by 3 and I can only divide it by 3. I am taking out a 3. There's 3 p's, there's 1 p, there's 2 p's, there's no p's. I can't take a p out. There's 1 q, there's more than 1 q, and there's more than 1 q. I can take out a q. Leaving me with 2p cubed plus 3p minus 4p squared q minus 6q. I would give you half credit for factoring out the GCF correctly. Now, it does have to be the GCF. Some people have just factored out a 3, which is only a common factor. We don't just want common factors. We want the greatest common factor, meaning as much as you can take out. Some people know that if you have a leading negative, you have to take out a negative, so they take out a negative, and then everything gets really weird. So, there are 2 ways of doing this. I'm going to show you how to do factoring by grouping using our box. So I started using the box back in Chapter 5, Section 2 for multiplication. Now we're going to go backwards because multiplication puts them together, factoring breaks it apart. There are 1, 2, 3, 4 terms, and there are 1, 2, 3, 4 boxes. You can go 1, 2, 3, 4, or 1, 2, 3, 4. Either way, kind of a zigzag pattern. 2p cubed plus 3p minus 4p squared cubed minus 6q. There is a leading negative. You must factor out that leading negative. But you can also take out a 2q. It has a leading positive, and we can take out the letter p. It has a leading positive, and we can take out a p squared. And we can take out a 2. Ooh. Look, this multiplication table works. This multiplication table works. It's like math works. And here, we can divide those both by 3, and that is a positive 3 because it has a leading positive. When we read this, we're actually going to read it going out that way, and these are our factors. Make sure that this 3q comes down to the answer. I'm leaving space because I'm going to show you another way of doing this. So one of those pairs is 2p squared plus 3, and the other one is p minus 2q. Hey, that gives you half credit. That's how you get this other part that would make it full credit. Yay. But I'm going to show you another way of doing this. The reason I'm showing it to you second is a lot of students make mistakes on this. They'll put parentheses here and parentheses here. They'll put a line here and accidentally make this minus into a plus. But what they're looking at is they're looking at the first 2 terms and they're looking at the second 2 terms. And that's fine. This is not a mathematical symbol that's going to change the meaning, but if you put the parentheses in, you can change the meaning, and that would be wrong. We're going to be factoring things out, which means that we're going to create extra parentheses. So I'm going to want to use a bracket here, and then I can factor a p out, leaving me with 2p squared plus 3. Here, I have a leading negative. If I have a leading negative, I have to take the negative out. I can divide those by 2q, and I'm left with 2p squared, and this is where a lot of students make mistakes, is they put minus 3. We took the negative out, which means that this becomes positive again. Also, because of GCFs, this in parentheses must match this in parentheses, or it's wrong. So, going on, we have 3q. We have our GCF from here, which is 2p squared plus 3. And then we have the leftover stuff, which is p minus 2q. Hey, that's the answer we got from over there. It's the same thing because math works. So, all we really need is, yes, I want to see you factor out the GCF. Either this way or this way, I want you to factor some more to get to the answer. Now, let's take a look at this. They're really the same thing. I took a p out and was left with 2p plus 3 when I started off with these 2 terms. I took a negative 2q out and was left with 2p plus 3 when I dealt with these 2 terms. It's really the same method, but this is what I see more in classes because we've been teaching it like this forever. This is a newer method, so some teachers are not as familiar with it, but I've had a number of students who said that it makes a lot of sense because if this is negative, that's negative, positive, positive, positive. And getting the signs wrong is one of the worst mistakes you can make when you're factoring. Chapter 5, Section 4, Question 4. Pictures. Pictures means labeling. All right. Find an expression in factored form for the difference of the volumes of the geometric figures. Difference means subtract. Sum means add. We will use those interchangeably in this problem, so be careful, you'll have to read, and that's why this is underlined. So the difference is we're going to subtract these 2, and I am going to strongly encourage you to leave them in the order that they are written on the page. If you change the order, you're probably going to get negatives, leading negatives that you'll have to factor out in order to get the answer fully correct. So over here we have 8x times 4x plus 1 Difference means subtract. 4 times 4x plus 1. This is a section on factoring by grouping and factoring out a GCF. So the first thing we're going to do is look for a GCF. Many students distribute this, combine like terms, and get a trinomial that they then have a hard time factoring. Don't do it. We have a GCF. And take a look. If we take this out, what we're left with is 8x minus 4. And then you might think, hey, that was really easy and I'm done. But you're not done because there is an evil math teacher here. We can factor out more. You will find this in some but not all of the problems because you are in Algebra 2, not Algebra 1. It's going to be harder. We're factoring out of 4. Remember, monomial goes before binomials. If it makes you feel better to have these next to each other, you can use the commutative property of multiplication from chapter 1 and switch the order around on that. But we're taking a 4 out, so we're going to be left with 2x minus 1. But wait, we have to label. This one is a volume. Volumes have a V equals. And if you remember, volumes get units cubed, areas get units squared, and everything else gets units regular. We have no units given to us, so therefore we will use the generic units cubed. That is our answer. So we have setting up the problem. That right there should get you half credit. The first factoring, if that's the last factoring as well, you could just put V equals in units cubed and you'd be done. But since you can factor a little bit more, you have to factor it completely to get the answer. And label it. Chapter 5, Section 4, Question 5, Type 1 of 2, Factoring Weird Problems. As you look at this, people are looking at it saying, wow, I have an addition problem in the exponent. That's not normal. But we've actually been doing this type of problem since chapter 1. Let's take a look. X squared times x cubed. I feel like we've gone over this recently, and we went over this in chapter 1, and it's going to be in chapter 7. X squared means x times x. X cubed means x times x times x. So these exponents are counting numbers, so if I multiply them all together, I'll do x to the 5th. All right. This says that I take these and I add them. That's what's going on here, is we added them. If I was to ask you to factor something like x to the 3rd minus x squared, I would always factor out the smallest one, x squared, and I would be left with x minus, hey, everything came out, so I have to have a placeholder 1 there. The reason that placeholder 1 is there is by the multiplicative identity from chapter 1 that says I can always multiply by 1. Some students, when they take out everything, they don't write anything at all. And then there's no way to distribute and get that binomial back again. So thinking about this concept and this concept, the first thing we want to do is factor out the smallest one. X to the a plus 2. Then, when I factor this out, I took 3 minus 2 gives me the invisible 1 here. If I have a plus 4, I took the a out and I took 2 out. What's left is the other 2. Many students will incorrectly leave an a on the inside and an a on the outside. But that would happen if I had 2 a's. I only have 1 a and it went on the outside. Now, if I was to multiply these together, it says multiply, but you really add a plus 2 plus another 2 would give me a plus 4, and it works. Continuing on, break down the symbol. Nothing is happening to this coefficient. I took out the a, and I took out 2, leaving me with invisible 1. Remember, with invisible 1, we don't have to write it there. Minus, I took out everything. Some students don't write anything, but remember, the multiplicative identity, there's a 1 there. That is our answer. This is actually a very fast question 5. That's because a lot of students want to do more with this. They want to factor this. But factoring trinomials, first off, this is chapter 5, section 4. Factoring trinomials is in chapter 5, section 5. I secretly did not have any of these that factored, but let's take a look. I can factor 1 as 1 times 1. Do 1 and 1, subtract to give you 2. No, they add to give you 2. If this had been a positive, I could still factor it. But since it's a negative, that is a non-factorable trinomial at this time of math. That is our answer. Don't worry, as you get into higher and higher math courses, we will be able to break that up yet more. But for right now, that's it. Chapter 5, section 4, question 5, type 2 of 2. You might look at this and say, this looks an awful lot like one of the question 2s from this section. And it is. I'm going to actually do it the same way. Some of you may not need to write this out 5 times. Or 4 times. But by writing it out this many times, you'll see that the GCF is 3y plus 1. Not only that, there's 1, 2, 3, 4, 3y plus 1's here, and 1, 2, 3, 4, 3y plus 1's here. There's a GCF. And that GCF is 3y plus 1 4 times. Bracket. We have leftovers. There's a 2x. That is a monomial which comes before the binomial. There were 5 3y plus 1's and we factored out 4 of them. One of them is still left. We have a minus x. And we had 4 3y plus 1's. We factored out 4 3y plus 1's. That's it. I would give you half credit for getting this far. Now, some of you might notice, we could actually have taken out an x, but almost nobody notices that. Good job. All right, we're going to leave it like this. We're going to keep going. We'll take it out later. 3y plus 1 to the 4th power. We're going to distribute just like we did last time and get 6xy plus 2x minus x. Remember to make sure that when you're distributing, that when you hit the end parentheses, you stop, because some students continue distributing over there. Oh, we can combine like terms. How nice. We can combine like terms because they both had x's. Make sure that you keep writing this. Many students write the 4, they write the 4, and then they stop writing the 4. Don't do that. We have 6xy. 2x minus an x gives me x, or 1x. And then you think you're done, but you're not, because remember that x that some students saw that they could take out here? It's still there, and it's still a GCF. When you factor that out, remember monomials go first, and binomials come second. And here, I took everything out. Remember from last problem? We're left with a 1, so it's still a binomial. And that is how you do that very long problem. I do need to see this step. I would need to see something like here, probably like this one. Definitely, I would need to see the answer. Yay, boxing the answer to make it easier for your math teachers to grade it.